physics department at Durham University is one of the biggest in the country, and our aim is to get real-world impact from our world-leading research.
I think as a physics department we have a wide range of skills that we can put together, and clearly the equipment that's needed to do experiments or make measurements associated with that.
We have a site in Durham City, which is where some of our optical labs are and where all our offices are and all our teaching facilities. And then we also have this site in Net Park, which is where we have our machining capabilities. So this is where we'll do all our optical design work, the manufacturing and the metrology, the testing of all the optical components and all the integration.
We have the expertise to try now and take this sort of theoretical or very, very experimental quantum technology and pull it forward into real-world applications, which could be for satellite communication as well as for measuring instruments down on Earth.
I lead the Free Space Optics group, where we study how light travels through the Earth's atmosphere. When you look at the stars and they appear to twinkle, right, we can build systems that go on the back of the telescopes which will in real time correct for that twinkling. We can take that technology, exactly the same technology, and we transfer it to emerging fields like laser communications and space surveillance.
I'm very interested in innovation, so every time I design some technology I try to push the limits of what is possible right now. I'm leading a project called Luces, that means lights in Spanish, in collaboration with UCL. Luces is funded by the UK Space Agency in order to develop the image slicer technology for applications in the extreme ultraviolet for the next generation of solar space missions. It will allow us to observe 2D structures on the Sun over 2 orders of magnitudes faster than the status quo.
I think there are lots of benefits of working with the physics department. One of the big ones is that we work on this full technology readiness level scale. Okay, so right from the prototype demonstrator level, the novel ideas, the concepts, right through to the product. And we've got experienced mechanical, electrical, optical, software engineers that can really develop that product.
The main thing is come and speak to us, come and talk to us, and we can then look, understand the problem, and then perhaps put together a multidisciplinary team with all the expertise to solve the particular challenges that are raised.
I'm totally open to work with whoever is interested in my technology for image slicers. It will be a pleasure to see that what we're developing here in Durham is useful also for other institutions, and I love to work with all of them.